Welcome guys. You are watching DSA Logic, your one-step solution for data structures and algorithms. I am Sheetal Chandra Nayak, a senior software engineer at Walmart Global Tech. In this video, we are going to learn about linked list, insertion or deletion. So if we have a linked list and we want to insert or delete an element from the beginning, from the end or from the middle, all we are going to learn that in this video. So keep watching. Let's start with insertion. Let's say this is our linked list and we want to insert an element at index 2. So this is the 0th index, this is the first index, and this is the second index. Basically what it means is we need to insert an element between these two nodes. So let's create our new node first. To insert an element at any position, basically we need a pointer to the previous node of the node where we want to insert the element. So in our case, we want to insert the element at this position. So the previous node is this one. So we need a pointer to point this node. Let's create the pointer. So here, and let's call it previous. Okay. Now this new node should point whatever this previous node is pointing to. So basically this new node should point to this node. Let's create this pointer. Now, the only last thing we need to do is move this pointer from here to the newly created node, and we are done. Now, let's try to insert an element at index 4, basically at the end of the linked list. For that, we'll have to create our new node. Let's create it. Now, we will need our previous pointer. So here is our previous pointer, which will be pointing to this node. Now, what we need to do is we need to point new node to the element where this node was pointing to, basically wherever the previous node was pointing to. As the previous node was not pointing to anything, means it was pointing to null, this also should point to null. So this is also not pointing to anything, this is also pointing to null. That's great. Now what we just need to do is this node should point to the new node. So we need a new pointer which should point from here to here. So let's use this pointer. That's it. It's done. So our same concept works when we have to add something to the end of the linked list also. Cool. Now let's try to add something at the beginning of the linked list. To add at the beginning of the linked list, we'll need our newly created node. So let's create our new node. Now there is a difference. We don't have any previous node here. So in this case, what we will do is we will point the new node to the head node. Okay. So new node will point to the head node and we will change the head node. So let's do that. That's it. So as you observed, basically adding something to the head of the list is slightly different than how we add at the middle or at the end of the linked list. Let's try to code to get some more clarity. To code the insertion logic of the linked list, first we need the linked list. So in our previous video, I have already created a linked list. I have created a very handy toString method and a main method and tested it out. So if you haven't watched that video, check the video flashing on the screen, or you can check the description box also. Please watch it before watching this further. To do the insertion, let's create an add method which will take the data and index. As we discussed earlier, the insertion logic to add an element at head or at any other position has a slight difference. To separate out that logic, let's create a if-else block. So if else, so in the if block, let's make it index equal to 0. So this if block will do the insertion at head, add to head, whereas the else block will take care of any other insertion. So in both the cases, we will need to create a new node. So let's create the new node. New node equal to new node of data. Adding to the head is very easy. we just need to make the new node dot next point to the head node, and we need to change the head to point to the new node. That's it. To insert the element at any other position, we will need the previous node first. For that, what we will have to do is we'll have to create a node, let's call it previous, which will start at head. Now we have to iterate through the linked list till we reach the previous node. So for that, we can make use of a for loop, and this condition will be index minus 1. So either we can write it like I less than equal to index minus 1, or we can start this for loop from 1 itself. So let's start it from 1 and make it index. Here we can do the previous equal to previous dot next. After this loop, our previous node will reach to the correct position. Now we just need to make the new node dot next point to the previous node dot next, and make the previous dot next point to the new node. That's it. Now is the time to test this logic. So we already have a linked list where we have added 10, 20, 30 and 40 in the linked list. This will print the linked list. Now let's try to add list dot add 25 at index 2, and let's print the linked list. So here the output should be like now let's try to add something at the beginning of the linked list. So let's add 100 at the beginning of the linked list, means 0 position, and try to print the linked list again. So after this insertion, the linked list should look something like this. And then let's try to add something at the end of the linked list. So let's add 200 at the end, and data will be 200. So 0th index, 1st index, 2nd, 3rd, 4th, 5th, 6th. So basically we want to insert at 6th index. Now let's test this out. So this is the linked list without any modification, 10, 20, 30, 40, exactly like we expected. Then after inserting 25 at 2nd index, we expected the output to be like this: 10, 20, 25, 30 and 40. Absolutely correct. Then we added 100 at the beginning of the linked list. So 100 is added at the beginning of the linked list, and this part is exactly like the same. Cool. Then we added 200 at the end of the linked list. So that also we can see is coming correctly. Now what if we give a index which is completely out of bound, like 10th index? So while doing that, this particular for loop will throw a null pointer exception. How do we resolve it? That's your homework. You can try that out and let me know in the comment section if you got it or not. Let's take a look at deletion. Let's say we want to delete this particular node. To delete this particular node, first we'll have to figure out the previous node, which is this one. Let's create a pointer at the previous node. Okay, so this is pointing to the previous node. Now we will need one more pointer to the node which we want to delete. So let's create that, and let's call this temp. Now the first thing which we need to do is we need to change the pointer. First thing we need to do is change this pointer, which is pointing to the temp node, to point to the temp.next node. Then delete the temp node's next pointer, which is this one, and we have successfully deleted the element. Now let's take a fresh linked list and try to delete the head element. To delete the head element, we'll need a temp pointer pointing to the head. So here is our temp pointer, which is pointing to the head node. Then We need to move the head to the head dot next element, which is this one. Once we do that, we need to delete the temp dot next pointer, which is this one. And we have successfully deleted the head element. Now let's try to code and get some more clarity. Now let's create the delete method. Actually, we can reuse a lot of code from our add method. Let me do the modifications first. As we are going to delete, so we don't need this data element. We only need the index. We will not need this one also. And we will not need these also. We will need to locate the previous node. So we'll keep this much code and we'll get rid of this one. Let's change the comments. Now, as per the illustration, let's create the temp node temp, which will initially point to the head node. Then head will point to head.next, and finally we will delete the temp.next link to make it null. So this will delete the head node. Now let's work on the deletion of any other node. Here we already have our previous node. So our temp node will be node temp equal to previous dot next. Now previous dot next will point to temp dot next, and finally temp dot next will point to null. Now let's try to test this out. To test it out, we'll need to call our delete method. So let's copy this and make it delete. Let's try to delete the sixth index first. So this is the last element. So it should delete the 200, and this should be our expected output. Let's try to delete some elements from the middle and from the head. So let's delete the head element 0. So our linked list output should look something like this. Now let's try to delete the second element. So it will delete this particular node. So our output should look something like this. Let's try it out. So we can see this is our linked list after deleting the last node. So it is giving the expected output 100, 10, 20, 25, 30, 40. Then we deleted the 0th index. So this one is gone and we have the remaining linked list. This is also absolutely correct. And finally we deleted the second index. So this one is gone and we have our linked list. Now if you give an index which is completely out of bound, so there is a chance you might get null pointer exception at this place or here. So that's your homework. Try to figure it out where you can get null pointer exception and how to resolve it. That will be a great exercise. Try to do it definitely. If you didn't get it, let me know in the comment section. I will create a separate video to handle the null pointer exceptions on these kind of scenarios. That's all for today. Let's meet in the next lecture. Hope you liked it. If you liked it, please like, share, and subscribe. Thank you so much.